Hi everyone. We're going to use the principle of mathematical induction to show that the given statement is true for all natural numbers n. Before we start, the ones I'm about to do that are numbered on your playlist, this one, they're starting to get harder here. So make sure that you know how to do the easier ones because I went into a little more details about condition 1 and 2. And here we're just going to, I'm going to assume that you know condition 1 and 2 have to be satisfied. So basically, condition 1 means we check for n equals 1. And that means we're going to plug in 1, and we're going to plug in 1 into this, and it should equal 1/2. So we have 1 over 1 times 1 plus 1, which equals 1/2. So that's true. And then we're going to try for condition 2. Assume it works for all k. If it works for k, so I'm going to write this equation again. But with I'm going to write this statement with k instead of n. And then we're going to check that it works for the next term, which is k plus 1. So basically, I'm going to copy this again. One over 3 times 4 plus dot 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 plus 1 over k times k plus 1. Now I know my next term is the one you're going to add. The term that comes after this term is 1 over k plus 1. And then the next term would be k plus 2. Okay, so that would be the next term. And then similarly, we do that on the sum. So the sum, we're going to have k plus 1. And then the next term after k plus 1 is k plus 2. So we want the left side of the equation to look like the right side. I'm going to try to squeeze it in here, and then I'm going to go to the next slide. So this equals this sum here, because these are the same. All right, so we have k over k plus 1 equals 1 over, not doesn't equal, it's plus k plus 1 times k plus 2. So I'm going to rewrite that on the next slide so we can do that. So we have k over k plus 1 plus 1 over k plus 1 times k plus 2. All right, so we're looking at this. We're going to find the common denominator. The common denominator of this is k plus 1 times k plus 2. All right, so when you're doing this, you ask what times your old denominator gives you the new. And that means basically what are you missing? You're missing this k plus 2. So we're going to multiply the numerator by k plus 2. Now the second piece, nothing's missing. So this is just going to be 1 up here because it's the same denominator. Now we can simplify the numerator and we get k squared plus 2k plus 1 over k plus 1 times k plus 2. And then we factor the numerator. This is going to be k plus 1 times k plus 1 over k plus 1 times k plus 2. Now these two cancel, and we get k plus 1 over k plus 2, which is what had to be proven. So condition 1 and condition 2 are satisfied. Therefore, the statement is true for all natural numbers n. Thank you and have a nice day. Bye-bye.